Hello and welcome back to another video. In this problem, we're asked to use Formula 10 to graph the given functions on a common screen, and we're asked how are these graphs related. So Formula 10, what they're referring to is the change of base formula, and in the particular textbook, it is log base b of x is equal to ln of x over ln of b. So we can see here that's not going to apply to three of these functions. We have y equals e to the x and y equals 10 to the x. These are standard exponentials that we can graph on their own. And I'll actually do this formula for y equals ln x to show you why it doesn't work. So if we have ln of x is log base e of x, that's equal to ln of x over ln of e. Natural log of e is just 1, so that's just ln of x, and we're back where we started. Where it is going to come in handy is log base 10 of x. I say come in handy. Most graphing software is going to have the standard common logarithm, but let's just do it for the sake of the problem. It's what they're asking us to do. This is equal to the natural log of x over the natural log of 10. And so we graph this function, which is, of course, just the original. We graph this one, which is the only one that's different, and then we do these two exponentials. What that gets us here is this graph right here, which I have prepared. And we can see two things. We have the general shape of the exponential functions, where it goes off to 0 as x goes to negative infinity, and as x goes to infinity, the value also goes to infinity. And we have the logarithm functions down here, where as x goes to infinity, these functions go to infinity, even if it doesn't look like they do because they get sort of horizontal. And then as x goes to 0, they go to negative infinity. And what we can see here is that they are reflected over the line y equals x, which I have in green right here. This is ln of x and e to the x. So because they're reflected, we know that they are inverses. Compare that to log of x, right? It almost looks like they might be reflected, but it's obviously not perfect because 10 to the x is the inverse. And there you can see it's a more perfect match where this is reflecting. So graphing these allows us to use Formula 10 even when it doesn't really seem necessary. But more importantly, it lets us see the relationship between the logarithm and the exponential, which is that they are inverses.